My name is Rebecca Schneider, and I am a graduating senior majoring in microbiology and minoring in chemistry. This summer, I will be starting as a graduate student at the TTU-HSC Graduate School of Biomedical Sciences to earn my PhD in biomedical sciences with a concentration in immunology and infectious diseases. I have been working as an undergraduate researcher in Dr. Kendra's Translational Microbiology Lab in the Department of Surgery at TTU-HSC. My research is focused on Pseudomonas aeruginosa, an opportunistic bacterial pathogen, and its role in hospital-acquired infections. My thesis is entitled Characterization and Source Tracing of Pseudomonas aeruginosa in the intensive care units. Patients in the intensive care units are often susceptible to this type of disease, as they have often experienced some type of severe trauma, such as a large burn, a severe wound, have had an invasive surgical procedure, or have some sort of underlying medical condition that causes them to be immunocompromised. Pseudomonas is found throughout the natural environment, as well as in man-made structures, such as hospitals. We were able to isolate Pseudomonas from water sources in the patient rooms in the intensive care units. Specifically, we found it to be particularly prevalent in sinks and sink drains in the patient rooms. Concurrently, we were collecting isolates from patients that were confirmed to have a Pseudomonas infection while receiving care in the intensive care units. We had hypothesized that isolates from the hospital environment and from patients would share similar characteristics, indicating possible close relatedness and possibly transmission from the hospital environment to the patients. To do this, we compared specific markers for severe infections to determine if the bacteria in the environment behaved very similarly to the bacteria that we had isolated from patients. Specifically, we looked at biofilm formation, which is a type of fortress that bacteria and other microbes can use to help increase their survival and endow increased antibiotic resistance. We also looked at various secreted virulence factors, including a variety of enzymes and toxins that the bacteria can use to damage the tissue and to better establish an infection in patients. What we found was that biofilm formation appeared to be important for the survival of both the environmental isolates and the patient isolates. Biofilm formation could be an important target for environmental decontamination and for treating patient infections. In the future, we hope to improve tracing methods and help healthcare providers prevent these devastating outbreaks from occurring among the vulnerable intensive care unit patients. I would like to thank my lab and all of the other wonderful people who have helped me with this thesis. Thank you.